Hello everyone, thank you for being here today. I am Fuad Alallah and my co-authors are Yumiko Sakamoto and Purang Irani from the University of Manitoba. The title of this paper is Exploring the Needs and Design for Situated Video Analytics. Humans are a very curious creature. They are in continuous search for technology that help us to rapidly access information about the surrounding and understanding data directly associated with objects, location, or other people. Technologies applied from situated analytics is emerging rapidly. Situated analytical technology drawn from domains of visual analytics and augmented reality to support a new form of in-situ interactive visual analysis. Due to the advancement in this domain, the possibility of visual analytics is also growing drastically. First of all, what is situated analytics? The concept of situated analytics is considered as the use of data representation organized in the relation to relevant object, place, and person in physical world for the purpose of understanding, sense-making, and decision-making. The emerging platforms such as mobile and wearable device has enabled situated analytics. One can ask, why do we really need situated analytics? Well, situated analytics supports data visualization, exploration, and sense-making. Let's look at an example. Imagine you are interested in buying a house while you are walking down the street looking for your dream house. Information about the houses start appearing in virtual signs as you pass by the houses. Information about traffic, such as rush hour, starts showing up virtually on the street. When you highlight the house of interest, more information are displayed to you. Now, we know that situated analytics is an emerging theme. However, there is no empirical study showing the actual effectiveness of situated analytics, so we do not know if situated analytics are actually better than non-situated analytics or not. Thus, we decide to move forward to empirically validate the potential of situated analytics in Study 1 by comparing situated versus non-situated analytics. Subsequent to this validation, we explore the methods to best design situated system in Study 2. In Study 1, we recruited 40 participants. They were randomly assigned to either situated or non-situated condition. All participants reported normal or correct to normal vision. Microsoft Bro 2 was used in both situated and non-situated condition. Participants in both groups were provided tools that helped them to answer the analytical tasks. Participants were presented with the following 5 video scenarios: projectile trajectories, movement direction, absolute measurement, duration of movement, action, and key environment changes. The dependent variables for each video scenario were based on exploratory search tasks found in the video analysis tool in the literature. The scenarios were acted out by 3 actors. 2 conditions for each scenario were produced on camera and off camera. An example will be shown in the next slide. In the key environment changed video, in the left side is on camera condition, where the video clip captured the entire action within the camera field of view, whereas the right side is off camera condition, where some part of the action happened outside the camera field of view. The general procedure were explained to participants. Participants were asked to watch video clip first, then perform visual analytics using the provided tools to answer questions related to the event in the video. Participants in the situated condition were instructed to walk around and gather information that could help them to answer the questions. The overall analysis of data shows significant condition and/or type scenes for projectile trajectories, key environment changes, and absolute measurement. In projectile trajectory, participants in situated group made less error, scoring 0.81 in on-camera and 1.91 off camera. This is show that being in the scene allow participants to view the video clips from different viewpoints, and this reduce their level of error. In key environment changes, participants in situated condition respond perfectly with a mean of 1 on color detection task, while participants in non-situated condition did poorly with mean of 0.18. In absolute measurement, participants in non-situated condition made significantly larger error with mean of 0.55 comparing to the participant in the situated condition with mean of 0.04. The overall analysis of user completion time show overall situated group took significantly longer than non-situated condition. This result was expected. Although situated analytics method improve accuracy, user move through the scene naturally increase the amount of time it takes to make a estimate judgment. This trade-off is further justified when we observe participant effort to be accurate. To assess participant confidence level regarding their own analytical performance, participants were asked a 7-point Likert scale question. How confident are you about the answer you provided above at the end of each task? When participants were in situated condition, their confidence were significantly higher with mean of 5.52 than non-situated condition with mean of 4.90. It's quite interesting that participants who were not in situated condition also indicate relatively high confidence, which was 4.9 out of 7, while they were significantly higher error. This is something that we should be paying close attention to. Currently, non-situated analytics are mainly used and their results are presented with high confidence but with higher error as well. This is indicate the benefit of our situated analysis. Due to higher accuracy in many domains, we can safely conclude that our empirical research yield better outcome for situated over non-situated analysis. Since the result of study 1 generally indicates significant potential for us to explore situated analytics further, we conduct an elicitation study which includes sketching and ideation activity for situated analytics. We recruited 12 new participants, none of them took part in first study. All participants reported normal to correct to normal vision. Each session was conducted with 2 participants. 2 participants are required so they could bounce back and forth their ID with their partner. A Microsoft Surface Pro 2 and Microsoft HoloLens were used. We recorded video scenario in a similar manner to that of study 1. All 5 scenarios were performed on camera field of view in one clip. We provided participants with A4 sheets of paper that have 3D representation of the location of the capture video. We provide participants with color pen to use in sketching activity. 6 workshop sessions were coordinated with 2 participants each. The session was conducted in a space where the video were captured. Participants were asked to watch the video on both Microsoft Surface Pro 2 and Microsoft HoloLens and walk toward the location where the event took place. Then participants were asked to discuss how they would visually represent an event in the video and sketch their visualization ID on the provided paper. A post-study interview with participants were conducted to explore participants' experience further. In total, 60 sketches were generated from the 6 sessions. The sketches you are seeing are examples of what participants generated in the study. Each digital sketches was summarized and analyzed in details. We systematically coded the transcripts, sort the sketches based on idea, analyze the use of different form factors in participant sketches, and create a summary for all findings with relevant quotes from the scripts. This process yielded three major components from the participant ID and sketches. In the information density level, we noticed that 60% of drawing capture important and relevant event with minimum amount of event data. On the other hand, 40% of the drawing fell into high density where more detailed information about the event is included, such as time, location, duration, and description of the event. In interactivity category, only 15% of sketches contain an interactive component. Various interactive functions such as clicking on the location of object or standing at the location of event to reveal more information were included as visualization interaction. In event narrative, annotation were used by some participants to directly instruct a user to explore further information or as a chronological order of events. 20.6% of sketches were narrative, whereas 78.4% were non-narrative. From the presented study, we come up with the following design takeaway for future consideration for designer as the following. Incorporate a low and a high level detailed visualization. Include the original video footage. Support event narrative. Incorporate multiple levels of contextual information. Incorporate embodied, cognitive, and embodied interaction. To conclude the presentation, we offer an early look at the video analysis activity and performance in both situated and non-situated settings. We confirm that user performance can be improved in the situated setting with heightened accuracy and confidence in their judgment task. The situated tasks naturally took participants longer as it involved physical inspection of the environment, but when we compare the cost and the benefit, we believe that benefit or higher accuracy outweighed the cost or completion time significantly. This paper further attempts to provide practical requirement and takeaway for situated video analysis design. A future direction for this research would be: first, follow-up study with experts to confirm what themes and feature that is important in practice. Second, implementing the situated video visualization sketches in mixed reality and virtual reality. Thank you. I'm looking forward to hear your questions.